here you can observe, as we are having the present state of S0, S1, S2 and S3, here write down them in the circle like this. Next you just observe the input part and the output part. Where the 0 is mapped to, 0 is mapped to 0, 0. In where? S0. So S0, it is self-mapped like this. So it is input, you write it in, you have to write input and then output. So 0 and hence it is 0, 0. Next comes 1, where the S0 1 is going as 1, 1. So it is going to S1 and it is 1 of 1, 1 in the 1. So next comes in the next state, it is S1, right? So next comes to the S1. In the S1, where is 0 going? It is going to S2 as 1, 0. It is going to S2 as 1, 0. Similarly, where is 1 of S1 going to? It is going to S3 as what? As 0, 1. As 0, 1. So this is how you have to write. And similarly next S2. S2 again it is for 0 and 1. Where it is going? 1 to S0, another one is to S1. So first S2 is going to S0. So here it is missing. You have to write it as 0 of 1, 1. And 1 is going to S1 as 1 of 0, 0. Again S3 it is going to 0 and 1, as 0 has 0, 1 and 1 is the self as 1, 0. S3 is going to S3. So this is how you have to write the state diagram. Next, coming into the code tree part. So this is one important one. Do listen to it carefully. Before writing the code tree, you should know the number of bits in the given message. That is L is equal to 5. Therefore, the code tree will have how many stages? It will have 5 stages. So this is the code tree, how it looks like. So first we will start with S0. So S0, this is the first point where we will start writing upward when it is 0 and writing downward when it is 1. Okay, this is for 0 and this is for 1. Now let's see, where is S0 mapped to? S0 is mapped to 0 as what? As S0 only. And what is the value it is having? 0, 0. So this S0 will go to the branch out as 2, and for the 0, 0 it is S0, and for the 1 it is S1. Where with the value of what? Output of 1, 1. Now we will move into the S0. So here in the S0 you can observe, as I said, it is again mapped to 2 as 0 and 1. For what is the S0 of 0 forms? It forms 0, 0. S0 of 1 forms 1, 1. Then what happens to S1 here? S1, if it is 0, it is mapped to where? If it is 0, it is mapped to S2 with what? 1, 0 as a output. So that is mapped to S2 with the value of 1, 0. Then again, if it is 1, S1 or where it is mapped to? It is mapped to S3 with the value of 0, 1. This is the first stage is completed. Next, we will move to the second stage. Here, you can observe, again, this S0 is 0. It forms S. Again, we are considering if it is 0 means what? It is S0 only. So this branch gets repeated again and the down branch gets repeated again here. The S1 and S2, S3. So finally, we will get S0, S1, S2, S3 in the upper part, as well as the S0, S1, S2, S3 in the lower part. But the values will be different because here you can observe S0 is branched to S0 when it is 0 and 1 to S1. Here it is S2. S2 is branched to S0 when it is 0 and S2 is branched to S1 when it is 1. So this is how it differs. So next stage is again this S0 gets splits here. So S0, S1, S2, S3. Then S0, S1, S2, S3. So similarly, you get it downwards. So how many steps got completed actually? This is 1, 2, 3, 4, 5. 5 is done. But also, you need to find the output now. Now let's see the message that was given is 1, 0, 0, 1, 1 was given in the question. So let's see the encoded output what we are getting. Let's see it. So firstly, for the 1, we will start with the S0. It is moving to what? 1. We will move downward. So 1, we got, what did we get here? We got our answer as 1, 1. So encoded part is 1, 1. So here, okay. Next after S1, where is it going? It is going to 0. So 0 means upward. So now the value what we have got here is 1, 0. Next, we are moving to upper part. Sorry, we are moving to next 0, that is downward. Downward means what? It is S1. What is the value here? Actually, it should have 1, 1. So the answer is 1, 1. Next is, again, we have to move to 1, means downward. Move downward. Here, the value is again 1, 1. So our answer is 1, 1. After that, again it is 1 only. So when you come to the S3 part, it is having 0, 1. Now the main part comes. So 0, 1, you got it here. Now again the S3, it is branched to 2 parts. That is S3 again what it forms? S2 and S3, S2 and S3. Again S2 is branched to 2 forms, that is S0 and S1. So here what again? After S3, where it is moving here, it is moving to 0, 1. So let us consider this state as nil. So but here we are getting it as 0, 1. And finally when you come up again here for the S0, it is 1, 1. So it is having 1, 1. So this is the encoded output what we are getting. You can check that this matches both the transfer domain as well as the time domain approach. Next comes the Trellis diagram. Okay. So here firstly you have to start with the uh, part that we are having. So basically what is the input that is being given to us is 1, 0, 1, 1, 1, and it is 0, 0. That is next we will be considering. So this is the one that is given in the question. So basically in the Trellis diagram here, if I represent a straight line without dots, it is considered as 0, and for 1 for the dotted line. So for this Trellis diagram, we need to have the state diagram to write this again. Okay. So here first, let's start. Write down the stages first. S0, S1, S2, S3 as the stages. So firstly, S0. S0 is mapped to what? 1 to the 0 and another one to the 1. So firstly, we will map it 0 as a straight line. And it is marked as what? 0, 0. And as a dotted line, so you can observe, and as a dotted line, this is 0, 0. This is for the 0, and it is 1, 1 when it is 1. This is the first stage. So similarly, write it again. So it is dotted line for 1 and it is 0 for the 0 part. Again, write it again. This is the third stage. So after writing this, we will move on to the S1. So here S1, what happens here? S1 is mapped to 0 and it is having S1 is mapped to 0 to what? S2 with 1, 0. So now S1, I am mapping it to S2 as 0, right? That is why I got the straight without dotted line with the value of what? Having the 1, 0 as the value. Now S1 is mapped to what? S1 is mapped to 1 to S3 with the value of 0, 1. So now this S1, I will draw a dotted line as 1 to the S3 with a value of 0, 1. It's not written here, it is 0, 1. Okay, so this one part S0 is done, S1 is done. Now we will move on to S2. In the S2, firstly, 0 is mapped to where? 0 is mapped to S0. So 0 is mapped to S0. In this S2 stage where I had stopped, I will mark the 0 to S0 as a value of 1, 1. And nextly, 1. Where it is mapped to S2, 1, it is mapped to S1 as 0, 0. So I have to map it to S1 has 0, 0. So now S2 is also done. Finally, S3. S3 here, firstly 0. Where is it mapped to? 0 is mapped to S2. So 0 is mapped to S2 as what? As 0, 1. And the 1 is mapped to self, that with 1, 0, 1. So I will map it straight here. So this completes the one complete circle for an Trellis diagram. Now you can observe here. You can observe here this part. So this part is done. So this part is done. You have to repeat that again to this part, and you have to repeat that again another one time. Same diagram what you have written, continue it without changing anything, as we need 5 stages. So next what happens? So the value is what? The first thing is you have to move in the 1. To move in the 1, as I said, you have to have, this is the first, is the I is equal to 0 path, and this is I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4, like that it moves. So now firstly what you have to consider is S0. So here firstly you have to move in the one path. So S0 has to move with 1. So to move in 1, this is the path that we are considering now. Just a So here you can observe this is the one that we are considering because of this one. Next what? Next I have to move from S1 to 0. So S1 I have to move in a straight line. Okay. Next in the S2 I have to move in the dotted line. In the S2 I have to move to the dotted line. Next in the 1 again I have to move in a dotted line. So again I will move in a dotted line. This completes this. Next again in the 1 I have to move to dotted line. Again it is dotted line. Next, so this completes the given value. Next it is up to our choice. So we are considering it as some 0, 0. So firstly we will move to this part, and next we will move to this part. And nextly we will move to this part. So this completes the code that they had given. So this is the line of code that we needed. Hence we, from this, by you now just followed this line. Now get those values. It is 1, 1. Here it is 1, 0. And next line it is having, this is having 0, 0. And this line is having 1, 0. And here it is 0, 1. And similarly, if you go here, you get the value. So hence we get the value of the output. So this was about the Trellis diagram. I hope you have understood it. Similarly, we are having some other problem. Same thing. First, you have to find out the generator matrix, then the state table. Then you have to write the state diagram. Then comes the code tree, and then comes the Trellis code and the output. Next is the recursive systematic conventional code. So these are described thus for the section that has been fed forward structures of the non-systematic variety. So this is another type of linear conventional code. Here that can exactly the opposite, being the recursive as well as systematic. So hence it is called as an recursive systematic conventional code. The diagram is given like that. This shows a simple recursive systematic code having the two distinguishing features which stand out. That is, the code is systematic. The incoming messages is mj is at the time j and defines a systematic part of the code vector cj at the output of the encoder. So now the code is recursive. The parity check vector bj is related to the message vector mj, has this equation with a modulo 2 addition. Now this works continuously in the transfer domain function, and then that is given as Bj is equal to 1 divided by 1 plus t into mj, where the transfer function is 1 by 1 plus t operates on the mj to produce bj. So here you can observe it consists of a message followed by the parity check of bj, and cj is a code set that is given by this, and bj we substitute as 1 divided by 1 plus t into mj. So hence the code generated for the RSC code is given by this equation. Next comes the Viterbi algorithm, that is decoding algorithm. Here, as usual, as we did for all the problem, find out G, then C is equal to D into G, find out C, state table, state transition table, state diagram, code tree, and then Trellis diagram, and finally comes the decoding algorithm. So in the decoding algorithm, first, as I said, this was the first step that we had taken for the S0. One is as 00 and the another one is as 11. Here, what is the actual RxD sequence? This is the RxD sequence that is being given by in the question itself. So in this, you have to compare this where Hamming code comes, where you have to compare the 11 with the 00 and 11. You can observe this, there is changes in the both the bits. So hence how many bits are changed here? 2. So the distance is Hamming distance is 2 here. Here it is both are same, so Hamming distance is 0. Next comes the step 2. So continue it. So in this stage what we are having 2 and we are having 0. In the next step, write down the next step what we had written in the Trellis diagram. So here we got 0, 0, 1, 1, 1, 0. But in this step you need to compare with 1, 0. Comparing with the 1, 0, how many, what is the Hamming distance here? It is 1. So here it comes as 1. And comparing with the 1, 1, it is 1. Comparing with the 1, 0, it is 0. And comparing with the another one, here it is 2. So now what? Here it is 2, here it is 1. So what will be the position of both of them? It is 2 plus 1 will get added up and it forms the 3. Again here it forms the 2 plus 1 has 3. Here it forms a 0 plus 0, 0. And here 0 plus 2, it is 2. In the step 3, what happens here is you write down the same thing what you have written here and you will continue one more step of the S3 part here. So what happens here is, here you have to compare for 0, 1 in the step 3. On comparing with the 0, 1, here you can observe what is the changes here. Here it is 1. Here for the 1, 1 also it is 1. For the 1, 0 it is 2. And for the 0, 1 it is 0. So already it is having 2, 1 and now I got 1. So what is the addition of that? 2 plus 1 is 4. Next, again here, come here again. So similarly, if you check here, here also it is 0 plus 1 plus 1 plus another one. Here it comes here, changing here, that is also 1. So it is 4. Again, you can observe here 1, 1. This gets changed as 1 also. So you have to consider in both the directions. So here also, if you consider it is T0 is 5 and T0 is 3. So out of all this, another one thing you have to note here is the 4 we had considered is for the upper direction, and the one that we had considered was from the another direction. So similarly here also, in a point meeting here we are having two paths. So consider the one sum having the least, that is having the minimum as the Hamming distance, and you have to reject the another one. So we have rejected here the 4, here also we have rejected the 4, here we have rejected the 5, and here we have rejected 4 and considered 3. This part is considered. So out of these things in the step 4, you can observe we have considered 1, 1, 2 and the 3. So this is the step 4. Similarly, write on the next step, and here you have to compare with the 0, 1. In this step, you have to compare with the 1, 0. So finally, after doing all these things, you will get by expanding the Trellis diagram, and finally you will get this diagram as like this. So hence you can say the decoded message is what? The original message that was given, you have to get that back here. So that is what we have got it here. So this completes the module 5 and the complete series of the digital communication subject. So do well in your exams. All the best for your exams. Thank you for watching, and do please like, do share and subscribe to Exam Ignite, and keep supporting. See you in the next video.